Okay, this is going to be the review video for the second part of the final exam review. Okay, so you can go ahead and take that out. The first question here, sine of m is 12 over 13. We're going to go ahead and assume that's in quad 1. And cosine of n is negative 3 over 5 in quad 2. Okay, so what I would do first is I would draw my m triangle. So since this is sine, this would be opposite over hypotenuse. So we know that the triple there is 5, and then the n triangle is cosine, which would be a over h, which would be 3 over 5, and this would be 4. Okay, since it's in quad 2, we know that that part will be negative there. Okay, all right. So sine of this formula is sine basically of m, cosine of n, plus cosine of m, sine of n. Okay, so the sine of the m triangle is 12 over 13. The cosine of the n triangle is negative 3 over 5. The cosine of the m triangle is 5 over 13. And the sine of the n triangle is 4 over 5. So that's negative 36 over 65 plus 20 over 65, which gives you negative 16 over 65. Okay, the b triangle, we're doing the cosine formula of 1/2 n. So that formula is plus and minus 1 plus the cosine of n all over 2. So if I look at what the cosine there is, cosine would be negative 3 over 5. So 1 plus negative 3 over 5. That's 5 over 5 if you're doing the common denominator, which turns into 2 over 5. Okay, I would divide that by 2, which gives me 2 over 10, okay, or 1/5, all underneath the square root. If I split that out, that's square root of 1 over square root of 5, and rationalize it, that's going to be plus or minus square root of 5 over 5, okay? All right, and then the part C of that is the tan of 2m, which that formula there is 2 tan minus, or 1 minus tan squared, okay? Of, in this case, we're doing m, so the tan there is 12 over 5. So 2 times 12 over 5, and 1 minus 12 over 5 squared. Now you could use a calculator for this. The top part would be 24 over 5. This bottom part would be 1 minus 144 over 25. Okay, all right, which turns into 25 minus 144 over 25, which gives me negative 119 over 25. Okay, so if you divide these, okay, what happens is that flips. All right. When all the dust clears from that, what you're going to end up having is the final answer is negative 120 over 119. Okay, and you can use a calculator to figure that out. That's how the math works there. Okay. All right. Moving on to number 2. Okay. Very simple proof here. All right. Secant theta plus 1 times secant theta minus 1. We got to show that that equals the tan squared. Very simply, that's a difference of squares. So that'd be secant squared minus 1 equals tangent squared. Okay, all right. And what we know is that secant squared equals, this is an identity that equals tan squared plus 1. Okay, all right. So if you substitute that in, these basically go away. You got tan squared equaling tan squared. Okay, pretty simple proof there. Okay, number 3, we got to prove that. We got cosecant squared, all right, minus cosine squared, cosecant squared equals 1. Now, since I see both cosecants, I would try to take those cosecants squared out. So that's going to be 1 minus cosine squared. Now, we know from our identity sheet that that sine is equal to this one, all right, and that all we know is that basically cosecant is 1 over sine, so that times that very simply would just be 1, okay? It's questions 2 and 3. Okay, question number 4, use the law of cosines. Okay, all right, what the formula you would use is b squared equals a squared plus c squared minus 2ac cosine of b. Okay, so pretty simply you put in 68 squared plus 52 squared minus 2 times 68 times 52 times cosine of 85. Okay, now what that ends up being is that b squared would be equal to, if you use your calculator, approximately this number. Okay, now in order to find b, what I gotta do is take the square root of that. Okay, all right, and so b is going to equal about 81.92. Okay, all right, very simple there. Okay, so that was question 4. Question 5, okay, they want us to find side b here. So I'm going to go ahead and draw this triangle out, OBT. And they told me that O, which would be this side, would be 19. So O, angle O, side O is 19. Okay, angle O is 170 degrees. Okay, side T is 11. So B we don't know, little b we don't know, angle T we don't know, but side T we do. Okay, so what this sets up is the law of sine special case. Okay, so there could be a possibility for multiple triangles here. So what I would want to do is I would want to solve for angle T, okay, over sine of 170 over 19, okay? And basically how you would solve that is that would go up, so sine of T would equal 11 sine of 170 over 19. And what you would do is you take the inverse sine of that, okay? And what the result ends up being, what I got, is that's going to be 5.7 degrees, okay? All right, so if you put 5.7 degrees for T, okay? Now, what you have to see if there's another triangle. Okay, so I have the O of 170, okay? Now, in order to figure out this other T, what I do is 180 minus that, 5.7, so that's going to be like 174.3. Now, the problem is here, we went too big with that, so there can't be a second triangle, okay? All right, and so then what I would want to do is figure out that this little side B, angle B would be 4.3 degrees, because that's got to total up to be 180. And then I would do sine of 170 over 19 equals sine of 4.3 over little b. I'd move the little b up, the sine 70 down, and the 19 up. So what I would have is b equals 19 sine of 4.3 divided by the sine of 170. Okay, and then what I got with that is about 8 or 8.2. Okay, either one works. Okay. All right. Going on to question 6. Okay, what's the domain and range? This is sort of a memorization thing we talked about a long time ago. All right, with sine inverse. Okay, you got to look at the domain and range. It basically flips from sine. So your range here, which is the most tricky, is negative pi over 2 to pi over 2, and your domain is negative 1 to 1. It's sort of the opposite of sine when it's the regular one. All right, cosine. All right, inverse cosine, the domain will be negative 1 to 1. The range will be from 0 to pi. Okay, and then for tangent, inverse tangent, we got a domain of negative infinity to infinity and a range of negative pi over 2 to pi over 2. Okay? We're going to skip question 7. We covered stuff like that in the other review. Okay, so we're not going to need to do that. Question 8, the 3 parts that define continuity. The first thing is that f of c exists. The second thing is that the limit, okay, as x approaches c, exists. Okay, and the third part is that f of c equals the limit as x approaches c. Okay, so those are the 3 parts of the continuity. Okay, question 9. All right, what you would do there is if you use some synthetic division, okay, you'd see that 1, multiply would give you 5, give you 6, give you 30, give you 6, give you 30. So that turns into x squared plus 6x plus 6. So what we know is, since that goes in there, that 5 is a whole or a removable, all right, discontinuity. It's a point. It's basically point, okay? Removable discontinuity, okay? Question 10. Okay, question 10. If I factored that, that would factor to x plus 8, x minus 3. The bottom, if I factored, would be x minus 6, x minus 3. That x minus 3, the solution for that would be x equals 3. So that's your removable, your point, okay? All right, and then what you're left over with is this, okay? Well, that bottom part of x equals 6, right, is an infinite or non-removable discontinuity, okay? All right, question number 11. So show the steps, okay? All right, now, the concept behind this, all right, this piecewise deal, all right? What you got to look at is, all right, this is for x is greater than 1, this is for x is equal to 1, and this is for x is less than 1. So the first part of this, the A part of this continuity, is to prove that g of 1 exists. Well, what we know is, at this point, we know that the g of 1 is 4. Okay? So this first part, this is the A part. Okay? Now, what we need to do in the B part is you make a table. Okay? You make a table. And the idea is we surround 1. Okay? We surround 1. And we surround 1 with 0.999, 3 of them, 0.992 of them, 0.9 that. The other way we go 1.001, 1.01, 1.1. Okay? Now, for this would be less than 1. So what you would do is you would put these numbers into your calculator. This would be a calculator, all right? And what you would get from a table result is like 271, 297, and then 2.997. Okay? Let me make that a little neater. 2.97, 2.997. All right? Now, when you get to this one, you plug into this, you substitute 1 into this function, make a table. Now, what this will say is this is 0.49, 487, and 4.4. Now, the problem is, all right, these are not approaching the same number. So that part doesn't work, so this would be discontinuous. Okay? What you would need for it to be continuous is both parts, as they approach 1, should be getting closer and closer to 4. Okay? That's the way it would be continuous. Okay? Let's go on to the last few problems. Okay? Okay, this last part involves the unit circle. Okay? So you should have memorized a lot of different stuff from the unit circle. I'm going to go ahead and put the important stuff up on the board over here. All right? The first thing are the 3 triangles. Those are important. The 30, the 45, and the 60, which 30 is pi over 6. So that would be 1, okay? This would be 2. This would be the square root of 3. The 45 degree, or the pi over 4 triangle, would be square root of 2, 2, square root of 2. The 60 degree triangle, or pi over 3, is square root of 3, 1, and 2. Okay? Now, as far as the unit circle goes, okay, we know this is 0 to 2 pi. This is pi and 90. Pi over 2 and 90. This is pi and 180. This is 3 pi over 2 and 270. We know these important points as far as the figuring out cosine, sine, and tangent. 1, 0, 0. So that's cosine, sine, tangent. Okay, for this one, it would be 0 for cosine, 1 for sine, undefined for tangent. Okay, over here, it would be -1 for cosine, 0 for sine. Tangent would also be 0. Okay, and then for this one, it's just cosine would be 0, sine would be -1, and tangent would be undefined. These will help you as you get to the other parts, okay? As far as pi measurements, we know that pi over 3, pi over 4, pi over 6 are in this quadrant, 2 pi over 3, 3 pi over 4, 5 pi over 6 are in this quadrant, 4 pi over 3, 5 pi over 4, 7 pi over 6 are in this quadrant, and we know that 5 pi over 3, 7 pi over 4, and 11 pi over 6 is in this quadrant. The other thing that's important is what's going to be positive. All the stuff will be positive here. In this quadrant, it will be sine and cosecant. In this thing, it will be tangent and cotangent. And in this quadrant, it will be cosine and secant. All of those will be positive. So this will help us quickly get through this stuff. If you're in this quadrant, you work here, here. This quadrant, you work to that one. Okay? All right? So if you look at 12, the way we convert is we just multiply by pi over 180. So that's 90 over 180, which is 1/2, is pi over 2. Okay? So very quickly, the answers for B would be pi over 4, pi over 6 would be 30 degrees, pi over 3 would be 60 degrees. I'm sorry, that's E, apologize. And then D, the 360 would be 2 pi. Okay? So I'm not going to overly go over that. That's how you convert it. Okay? 13, A. Okay, so tangent of 315. Okay, 315 would be in this quadrant. Okay, so it's in that quadrant, so I work to 360 degrees. So what I would have here is I would have the 45-degree triangle for this one. So I know the 45-degree triangle tangent would be square root of 2 over square root of 2. It would just be 1. The only thing that's going to be positive is that, so that would be -1 for that answer. Okay, the B part would be sine of 330. 330 is also in this one, so I'd work to 360. 360 minus 330 is 30 degrees. So that puts me in that triangle right there. So sine would be 1 over 2. Once again, the only thing would be positive would be cosine and secant, so that's going to be -1/2. All right, C, pi over 3. I know that's going to be in this quadrant. That's there. Secant, secant of pi over 3. Secant is h over a. So h over a would be 2 over 1 in that first quadrant, which would just be 2. D is cotangent of 45 degrees. 45 degrees is clearly that one. That's going to be a over o, which would be square root of 2 over square root of 2, which would just be 1. That's also still in the first quadrant. Okay. E, cosecant of 300 degrees. Okay. Cosecant of 300 puts me down there. All right, so 360 minus 300 would give me the 60-degree triangle, and I'm doing h over o. So 60-degree triangle h over o, which would be 2 over the square root of 3. And we work this out. If we rationalize it, would end up giving us that. The only thing positive is that one, so that's got to be negative there. Okay. Question F is cosine of pi over 4, which would just be this triangle right here, which would be square root of 2 over 2. It's in the first quadrant, so that is also positive. Okay. Question G, sine of 0 degrees. Okay, 0 degrees would be here, sine will be 0. Okay. Question H is secant of 30 degrees. Okay, 30 degrees is here, secant's h over a, so that's 2 over the square root of 3, which is 2 square root of 3 over 3. That's in the first quadrant, so it will be positive. Okay. I, tangent of 210. 210 puts me in this quadrant. I will work to 180. Never work to these. Always work to your x-axis. So 210 minus 180 would be 30-degree triangle. Okay, so tangent of the 30-degree triangle will be 1 over the square root of 3. If I rationalize that, square root of 3 over 3. Since I'm in that quadrant, that will be positive. Okay. J, cotangent of 150. Okay, I'm going to erase these up here so I can continue with those last two. Cotangent of 150, that means I'm in this quadrant here. I work to 180, so 180 minus 150 would be the 30-degree triangle, so that's the 30-degree. I'm doing a over o, so that's going to be square root of 3 over 1, which is just square root of 3. And this quadrant, sine and cosecant are positive, so that would be negative square root of 3. Okay? K, all right, I'm at cosecant of 390. Now, as you know, 390 is too much there, so what I would do is I would subtract 360, which would put me at that 30-degree triangle. which is that, which I'm h over o, okay, which is 2 over 1, which would just be 2, and it's positive because I'm in that quadrant. And the last question here is cosine of pi. That's going to be right there. We know that cosine of pi is -1. Okay, I think that this, if you were asking me what's one of the most important things you should know in going to trig, is that if you know this, you're going to be in really good shape. Okay, that's a big thing. And then we'll do the graphs on the following one. Okay, so if you go through that, practice that up, you should be fine.